Assalamualaikum. My name is Muhammad Afnan bin Jamal Abdul Nasir. The title that I will present is Flax Fibers Composite Effect of Fibers Orientations on Mechanical Properties via Ansys Simulations. Did you know the natural FRP composite has been widely investigated as a replacement for synthetic in polymer composite during last few decades? For this project, the natural fibers that I used to study is Flax FRP composite. First is I study about effect of fiber orientations on mechanical properties of Flax FRP composite. The effect of mechanical properties such as tensile, compressions, bending, and quasi-static. From this result, we will be compared with a synthetic FRP composite, which is glass fibers. The software that I use to modeling and simulation is Ansys software. The first problem statement is to know what is the effect of fiber orientations influence the mechanical properties of FRP composite. Second, reducing costs of conducting directive tests in the lab. Next, it's hard to find the effect of fiber orientations on mechanical properties of flax fibers composite in the literature. This is because there are only few articles report on the mechanical properties of Flax FRP composite that have been published. Most of the published papers discuss on experimental results. There are three objectives for this FIP. First, to evaluate the effect of layer sequence on tensile, compressive, bending, and cosmetic indentation strength and the deformations of Flax FRP composite. Second, to assess the effect of hole on tensile and compressive strength of Flax FRP composite. Third, to determine the effect of the supporting plate angle on the compressive strength of unidirectional laminate. Flax, also known as a common flax on Lignum ucitatium, is a flower plant that is one of the most widely used in biofibers. The pictures at the left show the flax flowers and the right show the flax fibers. The characteristic of the flax is low density, good damping, and vibrations absorptions. Flax fibers also can use to make kitchen towel, tableware, and also in automobile internal substrate. FRP is the one part of composite. We know that composite is combinations between two or more materials. Since FRP is under composites, therefore FRP is combinations fibers and matrix. The example of fibers is knaf, flax, jute, hemp, and more. For the fibers have a high modulus and strength, and matrix have a low strength. With these combinations, it will improve the mechanical properties of these materials. Now, many modern technologies need materials with unique characteristics that cannot be certified by standard metal, ceramic, or polymer materials. This is especially true for the material used in aerospace, automotive, marines, and constructions industry. For example, aircraft engineers are increasingly looking for structures materials that are lightweight, robust, stiff, abrasions, and impact resistance and corrosion resistance. As a result of this characteristic, FRP composite offer potentials in the industry. FEM and FEA methods are required in these switches of composite in order to complete mechanical tests such as tensile, compressions, flexural shears, and others. FEM and FEA is used to assist humans in achieve better and fast outcome. The modeling procedures for these projects was carried out with the help of FEM, built in Ansys mechanical APDL, which is suitable for analyze failures, deformations, and behavior of composite materials. Ansys was used to obtain the needed parameters of this project, such as maximum stress, deformations, and failures. This is table show the scope of work that I will do in FIP, the loading types of testing such as tensile, open hole tensions, compressions. The numbers of layers, tensiles, and compression is 8 layers, equal to 2 mm thickness. Fiber type that I use is Flax FRP. The software that I use is Ansys software. The simulations outcome is able to define the deformations analysis, stress, maximum stress, and maximum strain. This is the flow of this project. At the literature review, we need to find the mechanical properties of Flax FRP composite. Benchmark that we use in glass FRP composite. The technique that we use in simulations and modeling is Ansys APDL. At convergence analysis is to find the suitable mesh. At processing is to do boundary conditions and to find the degree of freedoms, and the degree of freedom is 1. The post-processing is to make sure the failure index is 1. Then we go to analysis part. At this process, to take the data from Ansys for maximums deformations for flats and glass. The final part is doing the report. This is mechanical properties for flats and glass FRP that I get from the previous research. At the convergence analysis is 2 determinations of mesh size used for the modeling and simulations of unidirectional flats FRP under tensile and compression load. Is very crucial to ensure the accuracy of the result, hence improve the reliability of it. This is because the greater the number of mesh size, the highest the accuracy of the value obtained. However, the greater the number of the mesh size, the increasing the times used to run the data in Ansys. There is a limit size for mesh in Ansys. Mesh size for 1 times 1 is not valid for this project since the boundary conditions are fully fixed at the center. However, for this convergence analysis, I only run from 2 times 2 until 32 times 32 mesh. As a result, mesh size of 8 times 8 was selected to be used to better accuracy of result. This is example for compressions for loading types. The white lines means the size of mesh. The yellow lines at the center is show the boundary conditions and the degree of freedom is 1. For tensile and compression tests, boundary conditions apply will be the same where center of model is fixed, where the displacement equal to 0 and the pressure apply at the both end of the specimen either tensions or compressions. So, the model assumed to have only 1 degree of freedoms during the both tests, which is displacement along x-axis. This table shows the result for flax and glass compressions with different orientations start from 0 until 90 degrees. This table shows the result for flax and glass tensions with different orientations start with 0 until 90 degrees. This is the example for displacement as x direction counter for 0 degrees laminate flax FRP composites. At the left show the compressions and the right show the tensions. The MS show the maximum of the displacement. From this graph show that for result compressions and tensors are decreasing. To verify that the modelings and the simulation using Ansys is valid, the data for maximum stress in 0 and 90 degree directions for tensile and compressions testing for flax FRP composite should be equal to the tensile strength, both 0 and 90 degrees obtained in the simulations. Therefore, this graph shows that the same values for 0 and 90 orientations. So, for result at the graph analysis is valid. In conclusions, the tensile and compressive at a 0 directions show the higher strengths than 90 directions. From the graph, the strength of a flax fibrous composite at any orientations angles can be predicted. That's all from me. Thank you.